When you see on my left hand side, this book is C++ Concurrency in Action, is the first edition. This book was released in year 2012 when C++ 11 standard was released, and this book on the right hand side is second edition. This book is released early this year 2019. In the first edition of this book, I found there is some inefficient code, so I purchased a second edition, but I found the same code. I mean the same inefficient code. In this episode, I will address why some of the sample code in this book is inefficient and how we can take advantage of modern C++ programming language. Hi everyone, my name is Thomas Kim. Today is June 12th, 2019. This is my 31st episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn how to extend C++ standard library container classes. We will make best use of C++ move semantic. More specifically, we will use std move make iterator. C++ Concurrency in Action, second edition, also in first edition in this book. In page 46 in case of first edition and page 49 in case of second edition, or page 52 in case of first edition and page 177 in case of second edition, there is a sample code like this, and also this function. In case of second edition, in page 177, this function is improved like this. It added this std move. Both of this function, pop function, it returns shared PTR of type T. This function is very inefficient. So this is thread safe stack. If the stack element is like million elements, returning shared PTR is very inefficient. Also in this case, pop function. To call this pop function, we have to create an instance of type T, and then we pass the instance as argument to this function. And in this code, the top of this data, this is stack is copy assigned. Both this function and this function is inefficient. We can simply fix like this. T we can say we can remove this or return value. If we modify function like this, this is most optimal, most efficient. This is most optimal and most efficient. In this episode, I will explain why this code is most efficient. And this function, returning shared PTR, is horribly inefficient. I will explain why. C++ Concurrency in Action, page 46, says that for those of you who aren't aware of the issue, consider stack vector int. Now a vector is dynamically sized container, so when you copy a vector, the library has to allocate some more memory from the heap in order to copy the contents. If the system is heavily loaded or there are significant resource constraints, this memory allocation can fail. So the copy constructor for vector might throw std bad allocate exception. This is likely if the vector contains a lot of elements. If the pop function was defined to return the value popped as well as remove it from the stack, you have a potential problem. The value being popped is returned to the caller only after the stack has been modified, but the process of copying data to return to the caller might throw an exception. This happens, the data popped is lost. Read this part carefully. The process of copying the data to return to the caller might throw an exception. But in this configuration, the process of copying data to return to the caller, the process of copying data does not occur in this configuration. First, this function returns R value. Second, we are creating value by move constructor. We are constructing value using move constructor. And since this is pure R value and this is named value, most of modern C++ compiler supports named return value optimization technique, and also if a class defines both copy constructor and move constructor in modern C++ language, the move constructor takes precedence over copy constructor. So the process of copying data to return the value to its caller does not occur in this function. Even if T is vector some type, the process of copying data never occurs in modern C++ language. Tom Cargill's article, Tom Cargill, Exception Handling, A False Sense of Security. This article was first published November and December 1994. This Tom Cargill's article, Exception Handling, A False Sense of Security, very famous article, published 1994 before first C++ standard. This article affected the design of C++ 98 standard. Tom Cargill's article, Exception Handling, A False Sense of Security, greatly affected the design of C++ 98 standard. Now the time has changed, and what Tom Cargill, worried about does not occur in modern C++ programming if the container supports move semantic and the element type of the container also supports move semantic. Technically speaking, both the container and the element type of the container should support non-throwing move constructor or copy constructor to use this technique. Luckily, C++ primitive type And POD type by default support non-throwing, move, copy constructors by modern C++ compilers. Also, most of modern C++ container classes support either non-throwing move constructor or non-throwing copy constructor, or both. cppreference.com, for example, std vector. This is std vector constructor supports non-throwing. This is non-throwing move constructor. I will post complete source code of this episode to my website, extensiontalkplayfun.com website. If you click this link and show in folder, if you unzip this file, in the subfolder tutorial, you will find the source code of this episode. I start Visual Studio, and in CPP extension folder, tutorial, click this button, O31, modern, CPP, hit enter. Ctrl V, include IO stream, include type traits. I will create a POD type, struct POD type, INTM, class aggregate type, public INTM. This is simple POD type, simple aggregate type. Void test non-throwing copy move constructors and assignment. I will create function main here, std cout std bool alpha, std cout does a primitive type support a non-throwing copy constructor. std is no throw copy constructable. std and there. I will copy once again. Does a primitive type support non-throwing move constructor? Move constructor. I will copy once again. Support non-throwing copy assignment. No throw copy assignable. I will copy once again. Does a primitive type support non-throwing move assignment? Move assignable. And I will copy the whole text. Copied, pasted. Does a POD type support non-throwing copy constructor? POD type. Then I say POD type. And I will copy this. And I will copy once again. Now aggregate type. I will copy this. Copy paste, paste, paste. Then this is aggregate type. I will copy this, copy this, copy this, copy this. I will copy this function, copy, paste it here, start command prompt, cl, we will try with Microsoft compiler first, cl, ehsc, std, C++17, O31, modern, cpp, cpp, fe, mexe, hit enter, m. So in case of Microsoft compiler with C++17 standard, a primitive type support non-throwing copy constructor, true. All is true. Move constructor, non-throwing move constructor is supported. Non-throwing copy assignment supported. Non-throwing move assignment supported. Also in case of POD type, also support all. Also aggregate type support all. Now let's try with clang std, C++17, O31, modern, cpp, O, cexe, hit enter. Sorry, cpp. Also clang compiler, all supports true. Now with GNU compiler, all supports true. So in this case, C++ primitive type, POD type by default support non-throwing move copy constructors. Okay? Now let's create a simple class non-throwing moveable. I will create a member private bool m invalid false public. This is default constructor std cout default constructor called std and l. This is copy constructor, right hand side std cout copy constructor called std and l. This is move constructor, right hand side std cout move constructor called std and l. We invalidate right hand side m invalid true. Now copy constructor, copy assignment operator constant right hand side. If this not true, std address of right hand side return this std cout copy assignment called std and L. Now I copy this. This is move assignment, right hand side, M invalid, true. Move assignment called. Now we create destructor. I will create a function here, void cleanup. If this M invalid is false, we can say std cout destructor cleaned up std and L. Now I copy this function, paste it here. Now we need to include a thread, include mutex, include stack. Here template, type name, element type, class, thread shape stack, private std stack, element type mdata, mutable std mutex mmutex, public. I will copy this. This is default constructor, void push, element type value. Here std lock guard std mutex lock mmutex mdata push. We can use in place. We will use push std move value, or we can say template type name types, void push types args std lock guard std mutex lock mmutex mdata in place std. We will use forward reference forward types args. This version is more efficient than this one. Element type pop std lock guard std mutex lock mmutex. If mdata empty, I will simply throw std exception. Otherwise, auto return value, I say named return value mdata top std move. Now we pop mdata pop return named return value. Now let's test this thread shape stack. We actually don't need empty, okay? Bool empty. This function actually is redundant. This function is redundant, but I will implement anyway. std lock guard std mutex lock mmutex return mdata empty, void test optimal thread shape stack, thread shape stack. We are using this object, and I forgot one thing. We have to put no except. It should not throw, and also it does not throw in case of operator no except is not supported. No except, okay? Non-throwing movable stack. Now we are pushing element stack push. non-throwing movable, we pass an instance auto top stack pop. Now let's run this code and let's examine. GNU compiler, hit enter. 142 I misspelled element type. I fixed CLS. I have to call this function copy paste. I will disable it. CLS G. Please note that default constructor is called. Okay? In this case, default constructor is called and move constructor is called twice. Destructor cleaned up. So destructor is called only once. Here it is first moved. First constructor is called, default constructor is called here. In the push, move constructor is called. Then probably here, in case of pop, move constructor is called. But instead of doing this, I will disable it. Ctrl K, Ctrl C, and I will create another function, another constructor. I will use int, and I will copy this constructor called. Then if we use this push in place back in place, then it becomes more optimized like this. For example, 1. GNU compiler once again, CLS G. So non-throw movable constructor is called. Okay? Here constructor is called only this case. In this function, the constructor is called only once. Then in the pop, at this point here, move constructor is called. And when this object top is cleaned up, then destructor is cleaned up. So we created only one object. No copy assignment, no copy constructor. This pop function, no expensive copy constructor of element type, no copy assignment, no move assignment. Named return value optimization kicks in only one move constructor, which does not allocate dynamic memory. Now let's think about this element type and this return statement. To give you better understanding, let's try with Microsoft compiler. CL EHSC STD C++ 17 031 modern CPP FE MEXE, hit enter, CLS M. Okay, please note this result. First non-throwing movable constructor is called here. At this point, non-throwing movable constructor is called. Internally, internal data structure stack, non-throwing movable constructor is called. And here, At this pop, move constructor is called. Move constructor is called here once. Now here at this point, to initialize stack, another move constructor is called. So this pop return move constructor is actually called through here to initialize top. Now if we give optimization switch O2, hit enter, CLS M, voila. Only one move constructor is called. So let's examine once again. In internally M data structure, non-throwing movable constructor is called here. At this point, it is moved, okay, and is popped. It is returned. This named return value is actually the address of top. Okay, once again, this named return value is the address of top. This named return value is actually top, the instance of top. What it means is this. We will print out the address of named return value here, std cout, the address of named return value, std and here std cout, the address of top and there. It should be std and there. Now let's build once again. I'm using Microsoft compiler giving auto switch, optimization switch, hit enter, CLS M. Please note that the address of named return value ends DB0 and the address of top is DB0. Okay? It means this variable named return value and the top is the same instance. When named return value optimization kicks in, the object name in the return statement only informs the C++ compiler of the object that is designated as return value. The real returning value occurs at this point. The real return statement occurs at this point. Now the real meat of this video is at this line. What if the type, element type, does not support move constructor? Luckily, most of modern C++ standard container classes support non-throwing move constructor. Also, primitive types and POD aggregate types also support non-throwing move constructor. So, the chances of failure of the following line of code is very slim. Even if element type does not support move constructor, such that copy constructor kicks in and the dynamic allocation failed, this pop function still holds, thanks to named return value optimization and copy reason. In some case, if an exception is thrown while copy constructing named return value, the invariant of M data still maintained because this M data pop-up will not be executed in the event of exception. So the process of copying data to return to the caller, this actually does not occur because of named return value optimization. Please understand that you have to understand the copy illusion and named return value optimization correctly. If you are uncertain of copy illusion and named return value optimization, please watch this video. In this video, I explained what is named return value optimization. Also, please watch this video. If a class defines both copy constructor and move constructor, and a function's return type is R-value or X-value, the move constructor takes precedence of copy constructor. So please watch this video. Move semantic and dynamic array. In this video, I explained the difference between copy constructor and move constructor. Also, I elaborated on move semantic. Also about no except move constructor. Is no throw move constructable? You can read more about is no throw move constructable in this C++reference.com website. Shared PTR is very heavy operation. Shared PTR is by no means free. It has its cost and is very expensive because it internally manages two distinct dynamic memory allocation, which is very CPU intensive operation. Please watch this video. How to implement shared PTR. By implementing shared PTR from scratch, you can have a correct understanding. I originally planned to talk about how to extend C++ standard library container classes in this episode, but this episode became too long. So in my next episode, I will explain how to optimize C++ standard library container classes. So I will change the title of this episode, Understanding Modern C++. I say correctly, understanding modern C++ language. Before I close this session, I will talk about this. This function is very inefficient. If you ever have to use pointer, then use unique PTR. Unique PTR is light, very light, and you can change it like this. Or return value make unique, and also here std move. Okay, then you can pop. This is the correct way. Note that we are using named return value optimization once again, and this unique PTR is very light. Whenever you need to use pointer, please consider using unique PTR over shared PTR. Shared PTR is very expensive. Even though C++ concurrency in action has some minor flaws, this is the best book on C++ multithreading. Don't fail to read this book. This book is a must read. Please subscribe to my YouTube channel. Thank you for watching.